The moon is our constant companion, always by Earth's side, yet we know less about it than about many distant planets. It shaped our oceans, controls the tides, changed our nights, and even stabilized Earth's climate. And still, even today, it hides mysteries. Polar ice, craters older than civilizations, and unknown structures that telescopes capture but cannot explain. In this video, you will discover how the moon was born, what hides on its far side, where water can be found, how it is slowly moving away, and what awaits it and us in the future. The moon formed more than 4.5 billion years ago after a catastrophic collision between the young Earth and a protoplanet named Theia, roughly the size of Mars. The impact created a disk of molten debris, which eventually merged into what we now call the moon. Oxygen isotopes on both Earth and the moon are nearly identical, proving a shared origin. Early craters and traces of a magma ocean remained on the surface, while lighter crystals rose to form the bright lunar highlands. The leftover molten material, rich in rare elements, fueled volcanic activity for billions of years. Imagine, this giant hot ball once glowed in the sky for hundreds of kilometers. The far side of the moon looks completely different. There are fewer dark maria, and the crust is much thicker. Grail mission data revealed that the average crust thickness on the far side is tens of kilometers greater. Telescopes show ancient craters that are difficult to explain with current models. Why is the crust so thick? Perhaps because of thermal contrast. The near side always faced Earth, while the far side cooled faster, crystallizing into a denser crust. There are also puzzling structures that don't fit into any known geology. What are they? Scientists are still searching for answers. Telescopes like the Lunar Reconnaissance Orbiter and advanced Earth-based optical systems reveal craters and surface details with incredible precision. They have recorded unexplained features, dark patches that don't belong to lava flows, strange bright streaks inside craters that change over time. No matter how accurate our maps become, the moon keeps surprising us. We are only seeing the tip of the iceberg. Just a few decades ago, the moon was thought to be bone dry, but telescopes and missions like Chandrayaan-1 and L-Cross discovered polar ice hidden inside permanently shadowed craters. Some of this water is endogenous, formed together with the moon, while some was delivered by comets. Isotopes show this mixed origin, and this isn't just scientific trivia. The ice at the poles could become a source of drinking water and oxygen for future colonies. For the growth of our channel, it's super important that you hit the like button, share this video with your friends and on social media, leave a comment, subscribe, and turn on the notification bell so you don't miss any new videos. The moon survived the era of heavy bombardment. The largest craters, such as the South Pole Aitken Basin, have been preserved for billions of years. Within them, we see the marks of shock waves and unusual rock formations. Some craters contain dark spots that telescopes have recorded, but their origin is still unknown. They are like ancient pages of a book we have not yet learned how to read. Water on the moon is slowly moving. Sublimation and cosmic radiation gradually erode the ice. Laser measurements show that the moon drifts away from Earth by about 3.8 centimeters each year. In hundreds of millions of years, its effect on our tides will change, and later it will appear smaller in the night sky. The water we now see in the polar craters may become the key to humanity's colonization of the moon. As the moon slowly recedes from Earth, the consequences for our planet won't be immediate, but over time, they will become noticeable. The tidal forces that currently regulate ocean levels will weaken. Tides will grow smaller, and the oceans will stop breathing as intensely as they do today. Earth's rotation will gradually slow down. The day will become longer, though this happens extremely slowly, just a few milliseconds per century. Over time, the rhythm of day and night will shift, affecting the biological cycles of living organisms. The tidal interaction between Earth and the moon also stabilizes Earth's axial tilt. As the moon moves farther away, this stabilizing effect will weaken, and Earth's tilt may begin to vary more dramatically. That would cause large climate shifts over thousands of years, making seasons far less predictable. Eventually, millions of years from now, the moon will be so distant that it will appear much dimmer in our sky. Its gravitational influence on Earth will weaken to the point that tidal effects nearly disappear. Still, Earth will not be left completely without its moon. The process is slow, reshaping our planet's dynamics step by step. Ancient rocks prove that the moon once had a global magnetic field. But how could such a small core sustain it? Perhaps massive impacts or Earth's tidal forces temporarily stirred the lunar core, strengthening the field. This magnetic field left traces in lunar rocks, traces that we can still measure today, offering clues about the moon's deep past. The polar craters are always in darkness. Their temperatures stay below the sublimation point of water ice, preserving it for billions of years. Telescopes detect bright and dark patches that change seasonally, even though the moon has no weather. This raises many questions. Is there more water beneath the surface? Does its amount change over time? These craters may hold the key to future colonies. On the far side of the moon, strange geological structures have been recorded. Bright streaks that shift over time, unusual crater colors, and mysterious depressions. Telescopes still cannot provide a clear explanation. Some scientists suggest these are remnants of rare magmatic processes. Others think they may represent surface effects that we have not yet discovered. The moon continues to intrigue us because even its familiar nightly appearance hides countless secrets. One of the main goals is to use local resources through in-situ resource utilization, ISRU. This will allow the production of water, oxygen, fuel, and building materials without transporting them from Earth. NASA is developing robotic systems like RASOR, capable of mining regolith, the lunar soil, to extract these resources. To provide reliable power during the 2-week-long lunar nights, NASA plans to build a 100-kilowatt nuclear reactor by 2030. This would guarantee stable energy for the base and its infrastructure. Lunar bases will become a critical training ground for missions to Mars and beyond. They will test life support technologies, medical systems, and radiation shielding under conditions similar to interplanetary space. The moon will serve as a practice field for future explorers. The moon drifts farther away, its water slowly vanishes, its pull on Earth weakens. Artemis and commercial missions are exploring the poles and the far side to uncover its secrets. Polar ice will become a vital resource, and the unknown structures may reveal new clues about the early solar system. The moon is not just a satellite. It is Earth's archive and a laboratory for the future of space exploration. And even though we see it every night, it continues to guard its mysteries, waiting for us to uncover them. If you enjoyed this video and want to see more episodes with fascinating facts, hit the like button, subscribe to the channel, and let me know in the comments which fact you like the most and what topic you'd like to see in the next video.